Hey there, mighty Texans. Looking at balance and unbalanced force fan cart lab. All right, guys, we are going to be looking still at balance and unbalanced forces. If you remember from your notes, balanced forces will have a net force of 0, so both sides will be equal. An unbalanced force is going to have a net force that is not 0. It's going to be greater than 0. All right, so one side is going to be stronger than the other. So when we're looking at our assignment today in Schoology, all right, we're going to be analyzing the effects of balance and unbalanced forces on the state of motion using Newton's first law. Remember, the first law is the law of inertia of motion, all right, law of inertia, where an object that is moving will continue to be moving unless an outside force comes into play. And a force is a push or pull. So when you look at your assignment today, all right, you're going to see, it says click on the carts. These are the little carts here to take you to the interactive website. Click on Part 1 tab at the top. Those tabs here at the top. Then click on the red circle for the cart to make the cart system move. So you're looking at clicking on the carts to take you here. Click on Part 1, and then you click on the circle to make a move. This one down here where it's cart 1. All right, you're going to see here, look at the speed here. It's asking, observe the motion of the cart, describe it. All right, you're going to describe it in your own words. You're going to tell me the forces are balanced or unbalanced because, and explain to me here. Then, if you look down here underneath the little cart picture, it says move the vectors. The vectors, if you remember from 6th grade, vectors are arrows that show the direction. Move the vectors to show the motion of the carts. Use only what you need. So you would click on, here we're going to have to go ahead and get out of. Let me go ahead and move this up. Get out of slideshow mode. And move the arrow to show the direction of the movement. All right, you're going to do this for each one. If you notice, there's part 1 here on slide 2, and then slide 3 has part 2 of it. The motion of the cart systems in part 1 and 2 are similar because, explain why they're the same. You're looking at just what you see. All right, don't think too much into it. You're just looking at what you see. And then it says here the forces are balanced or unbalanced because, again, go back to those notes that we did, the red and blue ones and the green and yellow ones. There's more information on there that you took. If you need to go back to those notes, those are still available in Tuesday's folder of this week. Go back into that folder to go look for them. All right, when you look at slide number 4, you got part 3, and it's telling you at the top specifically where to go and which circle to click on. Same thing for slide 5. All right, guys, and then at the end, you're going to go through and you're going to answer these here in online in Schoology. And then you've got this where it says star connection question. All right, guys, you're going to answer this question. The diagram below shows a sled moving along a smooth, frictionless, remember friction means there's no resistance. Friction is resistance, so if there's friction less, there is none. A frictionless track. and it has it in sections, section 1, 2, 3, and 4. In which sections of the track will the sled experience an unbalanced force? Remember, unbalanced forces again, net force equal to more than 0, 1 or more, and it will change direction, and it will start or stop. Balanced force just stays at rest. It does not move, does not change direction, does not speed up, does not slow down, and has a net force of 0. So with that in mind, you're going to answer this question. The answer is, and you're going to say which sections, because, and then go back in and explain that. Do not forget to click on submit when you go into Schoology so that I can go in and grade these over this next weekend. All right, stay warm, guys, and we'll talk to you soon.